everybody, and welcome to another live programming from the American Museum of Natural History. My name is Jackie Faherty. I'm an astrophysicist at AMNH, and I'm going to be hosting you today in this very fun program that we're calling Constellations. It is my absolute pleasure to introduce our presenter and pilot for today's field trip, Carter Emmart. He's the director of Astrovisualization at the museum, and he's a dear friend of mine. So, Carter, here we go.
Oh, I've been looking forward to this. OpenSpace is the software that is NASA supported, and you can download it yourself. If you're interested, you can type a message in the chat because we have some of our staff just waiting for your questions about that. But I want to take you into the sky. Jackie, you'll be monitoring questions, I guess, and so we'll be looking toward that. But I'm going to speak to you as if we're in the middle of Central Park in just a second. I'm currently up at my mom's house in Cape Cod in Massachusetts. So here we are. We're looking at starset, better known as sunset. And of course, our sun is a star. It took us a while to sort of understand that, but I might bring my little pointer into view just to show you that if we were standing right now on the Great Lawn in Central Park, looking west, we'll see the sun setting. And the American Museum of Natural History, the sun is setting just over that. Here's the museum. The Hayden Planetarium is just right around the corner of the building here, so it's sort of just slightly out of view. This is 81st Street. This is the Beresford apartment building, and then also the San Remo. Both have sort of twin little towers on them. And so looking west, we see sunset. Another thing that we'll notice is, maybe you can see it, I'm going to zoom in for us here, is the moon. So the moon is just, would be a thin crescent. I know it might be a little cloudy tonight, but what I'm going to do is just zoom in on the moon for us for a second so that we can see that. So let me just come up to my correct controls, and then let's zoom in, and then I'll just sort of aim down a little bit. But there you see the moon. Let me zoom in even more. Let's see. There we go. So it's just, it looks sort of like a black ball, which you'd see is a very thin little crescent. I always love seeing the moon that way, and I just thought we'd sort of start off looking toward sunset, as I say, and the time is set for 7 o'clock. So this is maybe dinner time for some of you, but also with the glow of the sky, and also, of course, the glow of New York City, what we see in the night sky is, you know, in a big city, we can see things in the sky. It's always kind of challenging. I grew up in New Jersey across the river, but taking classes at the Hayden since I was about 10 years old. So I learned the sky in the old Hayden Planetarium. And in the sky, we can see a bright star, Arcturus, it's yellowish. And then we see Spica. And so I mentioned that the sun is a star. So these are like suns, but very far away. They're glowing, luminous, gaseous objects. And if you want to know more about stars, you become an astronomer like Jackie is, and join the ranks of astronomers figuring out the universe. Now, what I've done is I started off looking west, and if I look downtown is south. And if I look south, we can see Central Park. We start to see the tall buildings around Midtown. But another star that we see is Antares right here. And this is part of the Scorpion. Now, at this point, what I'll do is I'll brighten the stars, because some of you might be saying, oh, it's hard to even see that. So let me just come up and go into my stars and make that a little brighter for us. So with that, I'm going to brighten the stars. And this is what you might see if you're in like a really nice country location, maybe up in the Catskills, maybe the Rocky Mountains, or maybe some of you, you know, even farther away, maybe even in another country. And so We see many stars now. We also see something else in the southern sky, and it's kind of exciting, and that is the Milky Way. Can you all see this sort of glow in the sky? I can make that a little more obvious for us as well. So just give me a moment and I'll go up and attend to that. Here, I'll make that a little brighter for us. We now know that this band of light that runs through the sky, in fact, if I pan up from looking downtown, I'll see that it goes across the sky, and we start to see other bright stars. In fact, if you were to stand out in a field, or even if maybe just your street looking up, you would see these three bright stars known as Vega, Deneb, and Altair, and they form what's called the summer triangle. Now, of course, we're going into autumn, but in early evening, around 7, 8 o'clock, you will see these stars above you. In fact, I always look for the first star. Usually the first star I see is Vega because it's pretty bright. Now, there are constellations associated with this. So what I'd like to do now is I'm going to turn on, let's see, the summer triangle constellations. So let me just move around just a little bit to show you them. There's Pegasus, it's blinking off to the right, so my apologies. So I'm going to try to just show you these. Now, we have two birds, which are glorious birds and beautifully drawn by James Hedberg, who can answer your questions if you're interested in his artwork, as well as his physics that he lectures about. Is that here's Aquila the eagle, and so its nose is sort of up here, Aquila. So Altair in Aquila the eagle. And then if we look farther along the Milky Way, we can see Cygnus. And if I turn on the constellations, I'm going to turn on constellations, let's turn on their stick figures that we see sort of star to star connection. That's another way to look at these constellations, is that if I just come back to Cygnus the Swan, is that we see this sort of cross structure. Sometimes it's called the Northern Cross because some of you may have gone to the Southern Hemisphere and seen the Southern Cross. So the bright star is the tail, Deneb. And so what I'll do is I'll turn the constellation stick figures back off. Now, Vega, which I've already pointed out, is part of the small heart called Lyra, the constellation. And now I'm just going to bow down back again so that we can see basically the skyline of New York, and I'm looking southeast. If I pan a little bit to the eastern sky now, from Central Park, I'm looking east and I see the Metropolitan Museum of Art, which is on Fifth Avenue, so on the east side of Central Park. That we were looking up and the stars, remember I made the stars quite bright. I'm just going to do this for a second. I'm going to bring the stars a little dim again because I want to point out some of the most prominent things you'll probably see. And you'll say, oh, I see two bright stars. Well, in fact, they're planets. And I've enlarged them a bit so you can kind of tell perhaps that this is Jupiter. And this is Saturn with rings, very small, but you need a telescope to really see the rings. But you will see these two planets in the night sky. And we've just passed Jupiter, we're passing Saturn. What does that mean? Well, the sun is setting. So the sun, we're as a planet, we're sort of coming between them. And so that we see Jupiter and Saturn. Mars would be rising later around midnight. So let me go. So we're looking east, we were looking south. I'm going to now turn. Oh, there's Pegasus. It's the artwork for Pegasus left on. And but I'm going to look north now. I'm looking uptown. I'm looking up toward Harlem, and from the Great Lawn once again, Central Park. And so we're looking north. And so looking uptown, you may notice something in the sky. I'm just going to call your attention to it. The Andromeda Galaxy. We've enhanced how you see it here. So it's looking a little brighter than it would be, but we would have to know the constellations to get there. I'm going to show you how you can do that. So I'm going to brighten the stars again so that we can just get a good feeling for seeing the stars and then drawing some of the constellations. Now we're looking north. We started with west. We looked south, then we looked east, and we're looking north. How many of you know that the word news is made up of north, east, west, and south? They're the directions, the cardinal directions around us wherever we go. And so I'm now just, I'm looking at another set of constellations. Let me come up and turn my constellations back on for us. Let me just come up here and I'm going to turn on all the constellation sort of stick figures that we see a kind of W shape. And this W shape is Cassiopeia. Cassiopeia, Queen Cassiopeia, this is her chair. She sort of sits in this chair. What I can do is, let me come down here. I want to turn on the constellation artwork for Cassiopeia. And I'm just waiting for that to work. Maybe I'm having a little technical problem. So let me just take the constellations that I have on. I'm going to turn them back off because these are groups of stars, and you know, different cultures have different stories. And but let me try to turn on now these constellations. And there we go. There's okay. A little technical problem, but now we can see Cassiopeia, and so she is a queen. And so this W shape that you might see in the northeastern sky is just sort of slightly above Andromeda, the constellation here. I'm going to turn the stick figures back on for us, constellations all, so that we can see that. And I'm just going to look over in this direction. Now we see the wings of Pegasus. So Pegasus is the flying horse that we see here. There's what's called the Great Square. And then what looks like the back legs of Pegasus are actually Andromeda. And so Andromeda was Cassiopeia's daughter, and she's being taken to safety by Pegasus, who's rescuing her from Medusa, who's been slain by Perseus. Stories from the Greeks, but I think the important thing is that I wanted to show you the Andromeda Galaxy, because if you can see it, you might see it with binoculars, just a slight glow. This is the farthest light your eyes can see. And we're going to talk about distance in just a few minutes, but this is a galaxy like our own galaxy. And the Milky Way that we saw, now if I just look up again for us, here. Let me look up. If I look straight up, we can see Cygnus and the swan and Aquila, the eagle, right here. And they're sort of upside down from the way we looked at it before. But there's New York. It's completely on its side. I'll turn this around. So now that we're looking along this band of the Milky Way, we now know that this is our own galaxy. So I'm just going to swing back around to looking north, because I want to show you one of the most famous asterisms in the night sky, and that's the Big Dipper. Well, the Big Dipper is part of a constellation called the Great Bear, Ursa Major, and so here we see the bear. Notice how I've gone all the way around. If we look down at the bottom, this is still where we're at sunset, but so the stars are just still coming out, but there's the Beresford apartment, and so we're just properly named underneath the Great Bear. And but then if I just look up here, what I want to do is turn off the artwork for a second, and I'm going to turn off the constellations that we've been looking at, so we can just see now, hopefully, here's this dipper shape. And I call it an asterism because what that means is a grouping of stars. You could kind of say, hey, this star looks like a funny face, or these set of stars looks like a funny face. We're all capable of finding interesting patterns. We look at clouds, we look at star alignments or asterisms of stars, but the Big Dipper is fairly prominent and seen by many cultures. But you may also know that the Dipper, the front stars in the Dipper, Merak and Dubhe, point to another star. And this is the North Star. And so there's a small constellation, a small bear that's here. Both Ursa Major and Ursa Minor, big and small bears, have long tails. Well, there's all sorts of stories as to why, because bears have cute little stubby tails. But nevertheless, in our constellations in the sky, they have long tails. What I want to do is bring the North Star just in view, toward uptown and toward north. And I'm going to now run time to 9 o'clock. So Jackie, while I do this, I'm sure there are probably tons of questions coming in. And so why don't we go with that? If you have any questions, I'll try to answer.
Yeah, and I can help answer them while you're getting set up too. So I can see we've got a lot of people in the chat that are probably students, and we're getting people from all over. I've seen India, I've seen Western Europe, I've seen, what else have I seen? Other parts of the US, and some great questions about whether or not the sky looks different depending on where you are on the planet. If you're watching from India, if you're watching from Western Europe. And you might want to try to answer that. Otherwise, I can.
Absolutely. In fact, one of the things I was just showing, maybe you saw it, and I kind of put the arrow on the North Star as I went from 7 o'clock to 9 o'clock, and the sky rotated around the North Star. And so in this way, the Big Dipper goes around the North Star, and Cassiopeia, remember, we were looking at it, and it's now higher in the sky. And so if the whole sky goes around this North Star, I'm going to pan back around to see it. It's not the brightest star in the sky. Some people think that's the case. It's like the 50th or 49th brightest star in the sky. What's important about it is that we have a star that aligns with how the sky rotates. Why does the sky rotate? We're going to look at that in just a second. But so if I even let time go a little faster, I'll do this time thing again. See how this star doesn't move. I'll put the arrow next to it, whereas everything else is rotating around. So this is getting way too late for a lot of you. It's probably way past your bedtime. So I'll just bring the stars back for us to essentially about, well, I'm going to try to stop around 9 o'clock. So. And then I'll point out some of the other constellations. Oh, we had seen in sunset, I mentioned the star Arcturus. And it's funny, you can use the Big Dipper. And once again, I'm calling it an asterism. It's part of a constellation, but it's another asterism, just part of the Dipper. 3 stars here essentially make up the handle, and they form an arc to Arcturus. And so we see it's a yellowish star. Stars have different colors. Jackie, why do stars have different colors? Maybe you can answer that while I bring up some more constellations so that we can see them.
Yeah, so Carter's going to bring up more constellations. And just a reminder, we're taking your questions in the chat, so make sure you put them in there. But you might be noticing that Arcturus has got this like yellow reddish color to it. Other stars, as we kind of move around, are
Aries red.
And Terry's another red one. Once we get closer to Orion, you'll see a little blue color going on. And all of that is giving you some indication of the temperature of the star, how hot it is. And similar to a flame, the hottest part of a flame isn't the red part, it's the blue part. So the bluer stars are your hotter stars, and the redder stars are the cooler stars. So right away, you've got more information than you thought when you go outside and you look up. So don't just look for, which one's the brightest, but also look for what are the colors of the stars, because that gives you stuff that as astronomers we use all the time.
So I've played with time here a little bit just to sort of bring back this band of constellations that perhaps you've heard of, the Zodiac. What sign are you? Well, we have 12 constellations that make up the zodiac. So the path the sun goes through in the sky. Oh boy, I'm going to have to explain that in a second. But the path the sun goes in the sky is through 12 constellations. And so what we see here is Virgo. And remember I mentioned there was Arc to Arcturus, and then Spica is another bright star, a bluish star, Jackie, and it's setting after sundown. And so Virgo, she is holding a spike of wheat, which is the star Spica. Its name is, and a spike is like a gathering of wheat. And so we can see her head is just sort of set, unfortunately. Oh, we also see the tail of something. This is Leo the lion. So the sun is right now between Leo and going into Virgo. Now, later on, it's going to go through Libra in October. And then in November, it's going to go through right here. Jackie, you said your favorite constellation, right? The Scorpion. Yeah. And if we go even farther, we're going to see right here is Sagittarius. Now, for a moment, let me turn off the artwork, because there's a beautiful teapot right here. Here's the spout, here's the top, and here's the handle. And it sort of pours the cream into the Milky Way, or pours the cream on the tail of the Scorpion. These two little stars, they form the stinger. It's Laseuth and Shala, the two stars. And notice how Jupiter and Saturn are right now in sort of Scorpius, and well, let's turn on the zodiacal constellations again. And as we pan again eastward, I'm seeing, oh, look at this, Capricorn. Capricorn is a sea goat. That's my constellation. And even farther along, we see this really nice depiction. Thank you, James. Again, this is Aquarius right here. Now, Pegasus, I'm still showing Pegasus, but Pegasus, maybe I should turn Pegasus off, because Pegasus is not a zodiacal constellation. So let me do that. Let me make sure I'm doing that appropriately. Yes.
As you're doing that, I just want to make sure I give a special shout out that I see that Carrie Brewer has his class in here. We're studying he's saying we're studying these constellations in class with the help of our Astro Lab Planetarium. My students are watching virtually today. Great reinforcement of content. So if you're part of Carrie's class, we're so happy to have you here. I hope you're getting some nice views of the constellation out of this.
What I'm going to do, Jackie, is I'm going to rise up off the Earth right now. And so here we are. We're taking the elevator up from Central Park. Well, there is no elevator there, but anyway, the concept is we're in a rocket and we're now launching. And as we do, we're looking west. And so we kind of see the sun rising, if you will, because we're climbing up through the atmosphere of Earth. There's the moon. You can just see it now. Virgo, we see her head and the atmosphere of Earth. The length of Manhattan is just about as thick as the atmosphere, where we see it trail off to black. So that we fly high in airplanes, but about 1/3 the distance of where the atmosphere starts turning black. You need to be in the blackbird plane to be sort of above that, 3 times the height a normal airliner flies. I haven't been flying lately. Some of you have not been either. With the pandemic, but still being able to travel around the Earth is an amazing fact of life, that we can fly in airplanes. And then, of course, in space, we're going to see our planet. We all live in space, really. We're on this Earth, but it's a planet. I'm now looking off toward California. I'll point out this is Baja, this is Mexico. And this is North America, and we can't see any borders here between Mexico and the United States or Canada. It's really just Earth. And so we'll pull farther back off our planet. And at this point, we'll also see sort of the night side. And we're starting to see parts of sky we didn't see, which were under the ground from Central Park, or what you would see in the southern skies if you were on like the southern part of our planet Earth. So one of the things I can point out is the Southern Cross, and also these are stars of the Centaur stars of Centaurus, and the brightest one, Alpha Centaurus. Alpha Centauri, this is the nearest star to us, and we'll actually see that in a second. But I'm going to pull around so that we see the night side. Of course, we're going to see the sun if we're seeing the the dark side of Earth, or the night side. We see Africa. And what I'm going to do now is just show you that the Earth spins. So what I'm going to do is go forward with time here. I'm going to go, that's 11 minutes per second. We see that's a little slow. Now let's do this. I'm going to see the Earth rotates, and it rotates on an axis. And so there's Asia, Africa, here come the Americas, and its Earth is rotating. Now, if I make it go even faster, let's try to actually let me slow it back down for a second. And I'm going to go hours per second now. So we're really going to speed things up. And as the Earth spins really fast, notice that the sun is going through Virgo. The sun seems to be going around us. This confused the ancients. What is this? Why does the sun? Oh, there goes the moon. That was that black dot. And we're now spinning the Earth so fast, day by day by day. We see the sun going through across the months. We've gone through September and now into October and now into November. And so let me slow us back down. And what I'm going to do is bring up the trails, the orbital trails of the planets. So, oh boy, there are a bunch of lines that just came on. And there's this line extending from the Earth. Well, if I move around like this, we can see that the Earth has this sort of trail extending away from it. And that I'm going to start time going again. Let's get that going. So now we have that. I'm going to make this go even faster. And now this perspective on those lines are changing. Let's move away from the Earth. There goes the moon. And we're going to see the moon go around the Earth. Now, of course, we all know a year takes 365 days. And that we have 12 months. Well, the moon goes around the Earth about 12 times a year. So you can see a month is like a month. And so now we can see how the Zodiac are where the, basically where the sun seems to go through as we go around the sun. Jackie, there may be some questions, and I know that what I've just shown is a lot of information right there.
Yeah, actually, I just want to go back to some questions that I think are really important. And I've been seeing you in here, Donna Lauro, I think maybe is how you say your name. One of those questions, it kind of goes back a little bit, but it was on whether the constellations are always going to look the way they do right now. An excellent question. That
really is a great question.
Yep.
So even though we go, we rotate, and so the sky seems to rotate around us when we're standing on the ground, but the Earth is a ball rolling, on an axis, and it doesn't rotate randomly. We rotate, that axis goes through the North Pole and the South Pole. And what I've shown you now is I've backed out so we see trails. These are marking out our orbital trail around the sun, and you can see closest to the sun is Mercury. It goes around in 88 days. It's moving fastest here. Next out is Venus. Then next is Earth and Mars. So these are the 4 terrestrial planets, and then Jupiter and Saturn. Now, this question about constellations, I hope I answered that question, that a lot of the constellations that we don't see, there are 88 constellations, the same number as keys on a grand piano. And I guess, or on any piano. So 88 constellations, 88 piano keys. And if I was to turn all of them on, I could actually, because that's quite beautiful. Let me try to do that. Let's see, I'm just going to come up to my constellation art, and I want to turn all of them on. Ooh.
And Carter, maybe while you do that, I can also.
That's having a problem, so I'm sorry with that.
That's okay. Yeah. I can jump in with some commentary here too.
Yeah.
As one of the things that I study is the motions of stars, where they are, how they're distributed. And so that question, Donna, I loved in part because part of why the constellations are not always going to look like this. Humans don't live for very long compared to how long things exist in space, but all stars are in motion. So the stars that we see and we connect the dots and we make these beautiful figures and tell our stories about them, it's transient. those stars are in motion, and they don't necessarily have anything to do with each other. So they will scatter off, and constellations will change. So part of what I'd encourage all these students in here, because I see many of you, I wanted to give a shout out to Mrs. Sherman, because you're getting a big plea from Olivia, one of your students, to make sure you get a shout out. That encourage your students to go outside and invent their own constellations. These 88 are just the ones that the International Astronomical Union has decided, but
That's right.
whatever shapes you see.
So one of the last things I want to show, and Jackie, is a really good point about everything is in motion. Here we see that we go around and in this sort of, it forms a flat plane, if you will, or you think of a pizza on a table, you know, so we're all sort of going around in this flat plane, which is defined by the early rotation, what formed the solar system. But you can see Mercury, and then Venus, Earth, and then the outer planets of Jupiter, Saturn, Uranus, Neptune, and also we see Pluto. It's a minor planet, or a dwarf planet, but still we put Pluto in there. It's just beyond Neptune, if I get the perspective right. But so everything is in motion, including the stars. And what I want to do now, Jackie, is I'm going to move us far enough away, in fact, to begin to see stars in motion. So in motion to just not them moving like I'm showing the planets, but what I'm going to do is move away from the solar system. As I do, actually, I should say one last thing. I want to talk about distance. You might wonder how far away the sun is. Well, the sun is about 93 million miles. And we also discovered something when we started to try to make better and better clocks, was that we saw the moons of Jupiter, and they go around Jupiter almost like a clock. But depending on how far away Jupiter was from us, see how right now, the way I'm showing it is we're on the opposite side of the sun from Jupiter. Actually, because I've advanced time, right now we're actually sort of here. We've just passed Jupiter. But we noticed something with the clock of the moons of Jupiter that indicated that light actually has a travel time. And depending on how far away we are, say, from the clock we're observing, the moons of Jupiter, it had an effect. We now know that the light from the sun takes about 8 minutes to get to us. It's the fastest moving thing we know. 186,000 miles a second is light. So if the sun is 8 light minutes away, the nearest star, and I've put it down here, Alpha Centauri, is, you might say, well, maybe it's, you know, a few hours away. It's actually 4 light years away. And a light year is the distance light travels in 1 year. It's about just shy of 6 trillion miles. And so as I pull out, we're marking where the sun is. And now we can see that Alpha Centauri has come off. Notice how the constellation artwork starts to move. I'm going to turn off the artwork. So let's do that. And we're just left with the stick figures now to give you a sense that all these stars are out there at distances that astronomers like Jackie have measured. In fact, Jackie's involved in one of the greatest star measuring experiments ever done, the Gaia mission. And we see stars all around us. Remember I mentioned Altair and Vega that we could see in the summer triangle, and Deneb. If I just come in, the 2 stars closest to us, this is Sirius and Procyon, about 10 and 12 light years away. And you say, where's the sun? Well, the sun is in the center. This is Altair, 16 light years away, in Aquila, the eagle. And in the little harp, Lyra, is Vega, 20 light years away. And then the star Deneb, the tail of the swan. Oh, I meant to tell you that if you do have binoculars or a small telescope, if you look at the nose of Cygnus the swan right here, or the eye, that's a beautiful double star that's sort of orange and blue. It's one of the most beautiful double stars you can see in the night sky for contrasting color. So as we pull out, we can now see that that star Deneb is hardly moving. That star Deneb we now know, is about 2,000 light years away from us, very far. And notice how the constellations, now we see them in 3D as we move out. And so, Jackie, I'm going to pull out even farther. And if you want to say a few words about, you've already mentioned how we're all in motion. And I'll level the Milky Way for us, because I guess that's the last thing I'll just draw attention to here is the system we're part of. Yeah.
I think we're running towards the end of the program, so I also want to make sure we've got so many students in here, and it's so great to see so many of you in here. A few last shout outs for some classes that are in here. Looks like Mo Kayali, you've got first, second, and third grade classes that are in here. I think there's Mrs. Yvonne. I have to give you a shout out as well. And for those that have been watching and feeling this out constellation wise, I hope you are super excited to also go outside and look up, because everything Carter's showing you, you have the potential to go outside and look up and see some of these things in action. It's wonderful to see it on the computer here, but we also have our eyeballs and our ability to go out in the dark. Think of it as your Netflix or your Hulu or whatever you use. Your evening experience should be going outside and looking at the stars for a little while. You should.
Well, really, the star constellations come from generations of when, before cities, where the night sky was basically what was available at night, sitting around a campfire, telling these stories passed on by oral traditions. I brought up a sphere, and that shows how far radio signals have reached out. Radio is a form of light since around the late 1930s. And so this represents basically how our technology in the form of radio light has reached out about 80 light years. And so this shows how far we have sort of, if you were an alien out there listening to us, and that this is how far that radio has gotten. So beyond that, nobody's out there has heard from us. But notice how some of the stars and the constellations that we see are inside this sphere. And so that's what's in here. And notice Andromeda. I showed you in the beginning. There's Andromeda, that little galaxy out there. The last thing I'll leave you with is just moving out from our region of the galaxy and the constellations that make basically the constellation stick figures we see here. And the last thing I'll do is move out away from our Milky Way. Now we see how the constellations just occupy this small part of our Milky Way galaxy, and that Andromeda galaxy is much farther away. It's about 2.5 million light years away, and so there's us. And now we see not stars but other galaxies. And Andromeda is moving a little slow there, but Andromeda off to the left is about 2 million year old light. And that's the farthest you can see, even from Central Park. This has been a lot of fun to bring all this to you today. Jackie, I don't know if there are any questions or whether we should end the program, but there's so much to say, and I hope some of you can go out and look at these constellations.
Yeah, I think we're going to have to end up here, and thank you all for joining us today. There have been so many great questions. There's been so much great chat. So many students that are here with us. I have a couple of things to announce as we go out. So thank you, Carter, so much. That was great. And Open Space is such a wonderful piece of software. A reminder to have a survey. Yep, Carter's got the shirt. We've got swag, shirts, stickers, the whole thing. We have a survey, a reminder that if you fill out the survey, our friends at NASA really want to know what you think of the programming, like what do you like, what do you not like. We'll be sending, if you fill it out, the first 30 people will get mailed to their home or apartment or wherever you are, a NASA logo sticker, which is very exciting. As I've said, I've got one on my laptop. It's got shows you've got cred, space cred.
And NASA supports open space, so that's how it's been developed in collaboration with NASA and support by that.
Yes. NASA supports this software, and we want to support. Thank you very much, NASA. And we want to support you guys for watching and by giving you this sticker too. The other thing is that the Museum of Natural History in New York City is open. It's timed ticketed entry. And visit amnh.org in order to get your tickets already. Hayden Planetarium remains closed. These tours with Carter, myself, a couple of others will be us bringing you the Hayden Planetarium, right, Carter, for a little bit of time here.
We can't wait to get back.
We can't wait to get back, but we're not back quite yet. And very, very exciting. I want to make sure I drive this point home that we have a graduate school at the American Museum of Natural History. And if you are a prospective science teacher, you'd like to be a science teacher teaching earth science, apply for the museum's Master of Arts in Teaching degree. Every student gets a full scholarship plus a $30,000 stipend for the 15-month graduate program. I'm an instructor in it. I teach the space sciences class. You might have me as your instructor for that. Go to amnh.org/MAT. Sign up. It's amazing. It's an amazing program. So I would encourage you to do that. And last but not least, next week at 1 o'clock, we are going to be live premiering this past year's Isaac Asimov debate that was hosted by our very own director, Neil deGrasse Tyson. It was on life, aliens in the universe. So if you want to catch that, tune in next week at 1 o'clock p.m. And I think that's it. That's a wrap, right, Carter?
Thanks, Jackie. And thank you all. Thanks for coming back and visiting us in whatever way you can.